Alright, in this video we're going to have a look at combinations of any number of objects. So basically we're selecting R where R can vary between 0 and n. Okay, so I might be selecting 0 objects, 1 object, all the way up to n objects. Here's an example. In how many ways can a group of at least 1 be selected from 7 people? Well, method number 1 is a bit long, but it works. If I want to get a group of at least 1 selected, so it's a selection and it's a group, it's going to be a combination. Order's not important. I've got 7 people, I could select 1. I've got 7, I could select 2. I could choose 2, I could choose 3, and I could keep going up till 7 choose 7 is the maximum. And I can put that in my calculator and work out that it's 127. Okay, that's one way of doing it. It takes a little bit of effort to put all that into your calculator. It'd be nicer if we could sort of look at the complement of this situation. So the complement of this situation would be all possible group sizes minus a group size of 0. So it'd be nice if we could look at all possible group sizes minus 0 members. The problem is that we don't have a way yet of working out how do you work out how many combinations there are that we can make with all possible group sizes if R is allowed to vary. Okay, it's sort of like, well, maybe I could do 7C0 plus 7C1, blah, 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 but that's just ridiculous, and then minus 7C0 at the end, that's ridiculous. So maybe there's an easier way, and this is what this second method is. So the logic behind it is we place one object at a time, and we note that each object can be dealt with in 2 different ways only. It can be included in the group, or it can be not included. So this is what you picture. You picture you're in or you're not in. And we bring the first object, maybe it's A. It's got 2 options. It can be in or not in. Then B can be in or not in. C can be in or not in, etc., etc., etc. And there's n objects altogether, right? Or in this case, there's going to be 7 people, so there's going to be 7 different outcomes. So you can think of it like this: 1, 2, 3, 4, 5, 6, 7. Each is 2. You can either be in or out. And that gives us all possible group sizes. And then minus the 0 member one, which would be 7C0. We're choosing 0 from the 7. So that's 2 to the power of 7 minus 7C0. 7C0 is 1. Okay, which is 127. So that's the other alternate way of doing that particular question. And it does work out to be a little bit quicker to use this method 2 shortcut. Okay. What's interesting is that the above example gives us a way to calculate all combinations for any number of selected objects. So the total number of combinations for any number of selected objects, which would be NC0 plus NC1 plus NC2, etc., all the way to plus NCN, is always going to be 2 to the power of n. Because each of those n objects has 2 options. It could be in or out. So we multiply 2 n factor times. Okay. But beware, this includes selecting none. Okay, the NC0 is the selection of none. Okay, if the question asks for a number of selections with at least 1 object, it's going to be 2 to the n minus 1, like how we did in the previous example. All right, let's have another look at another question using the same sort of method. So we've got a set 2, 4, 6, 8, 10, 12. It's the first 6 positive even numbers. How many subsets contain at least 2 numbers? Okay, so at least 2 numbers. Well, we could do, there's 6 numbers. We could choose 2. That would form all the subsets with 2. By the way, one thing important for subsets, order doesn't matter for subsets. Order, not important for subsets. Okay, so we could do that, we could do that, we could do 64, 65 plus 66. That's not too bad. You can work that out. Or let's try and use this shortcut way, which would be, well, I've got 6 numbers there. So groups of any size, so all group, or I'll say all subsets minus 0 members and minus 1 member. And that would make it so that it's at least 2. So all subsets would be 2 to the power of 6. 0 member would be 6C0, and 1 member would be 6C1. Okay, either way, both ways you should get the same answer. And the answer is 57. Okay, that's A done. B, let's try and do B. How many subsets with at least 2 numbers do not contain 8, but do contain 10? So 8 is not involved. 10 is in the subset. 10's in there. Okay, so think about it. If that means that I've got really this set here that's left. What's left would be 2, 4, 6, 8 and 10 have been used up, and 12. I've got 4 left. I've already picked 1. So when it says we need at least 2 numbers, I've already picked 1. We need to pick at least 1 more. At least 1 more. Okay, so 1 more from 4. So we basically want to know how many groups can we pick of any size, at least 1 or more from these 4. Okay, so you've got 2 different ways. You can do it there's 4 objects. We could choose 1, we could choose 2, we could choose 3, or we could choose 4. Or equivalently, we can do all subsets minus 0 members, not included. So that'd be 2 to the power of 4. Okay. Minus the 0 member 1 would be 4C0, which is just minusing 1. Okay. Either way, we get an answer of 15. Okay. Up to you which method you use. I do recommend when n gets large, this second way of using all subsets with 2 to the power of n is much quicker when n is large. Alright, so that's kind of us selecting one group with different amounts of items. Let's have a look at selecting multiple groups, and we're going to look at equally sized groups, and we're going to look at distinct versus indistinct. Okay, let's have a look at this question. So how many ways can 8 people be split into 2 distinct groups, each containing 4? Okay, let's talk about what distinct group means. Distinct groups means that the 2 groups are different. So we've got like group 1 and group 2, and they're different. Okay. So let's think about it. We've got 8 people. For the first group, we're choosing 4. Okay. 8's going in, we're choosing 4. And then for the second group, we'd have 4, and we're choosing another 4 to make that group as well. So we're times by 4, C4. Okay, and 4C4 is just 1. Okay, because if you've got 4 people and you're selecting 4, you can only do that in one way. Either way, you get 70. So the answer for A is 70. B is the exact same question, except they said the 2 groups are indistinct, each containing 4. Okay, so I'll give you an example of what's going on here. So imagine you've got A, B, C, D in group 1, and you've got E, F, G, H in group 2. And imagine we switch that. So E, F, G, H is in group 1 and A, B, C, D is in group 2. If the groups are distinct, these are two different options. Okay, because you're in team 1 or group 1 compared to in group 2. But if they're indistinct, if they're identical, they are the same. We need to knock something out. So the key thing is when they're indistinct groups, I might say indistinct K groups. Well, here it's going to be 2 groups. The key thing is that you need to divide by K factorial. Okay, so here there are 2 indistinct groups, so therefore we take the same procedure as last time, 8C4 times 4C4, and we're going to divide by 2 factorial. Okay, and when we divide by 2 factorial, we'll get an answer of 35. Okay. So that's for equal size groups, distinct versus indistinct. Let's have a look at another one here. We've got 12 people divided into discussion groups. There are 3 groups, each containing 4 people each. So we start off with 12. We've got a group of 4 here. And then we're going to have 8 left. And then we're going to take a group of 4. We're going to have 4 left. We're going to take a group of 4. Okay, so that's what we've got. But you'll notice that there's nothing that distinguishes the 3 groups. Yeah, so let's have a think. We can do 12C4 times 8C4 times 4C4, but we need to divide by, we've got 3 identical groups. 3 identical groups, which tells us that we need to divide by 3 factorial. Okay, so let's quickly do that in my calculator. 12C4 times 8C4 divided by 3 factorial. So it's 5755. 5775, sorry. Okay, next question. We've got 8 people divided into 2 distinct groups. Now it doesn't say that they're equal groups, but it does say that they're 2 groups, which means that you can't have 0. Okay, because if you've got 0 in 1, you don't actually have 2 groups. You've only got 1 group. Also, one group can't be full because then the other group has to be 0. So this means non-empty. Non-empty. So no 0 members. 0 members are not allowed. In how many ways can this be done? So we've got 2 distinct groups. So you imagine you've got group 1 and group 2. Each person can either go into group 1 or group 2. So the first person's got 2 options, second person's got 2 options, etc., etc. So it's going to be all options minus the one way of putting everyone in group 1 and the one way of putting everyone in group 2. So minus 1 minus 1. So all options, well, we've got 8 people. So remember it's 2 to the n. So all size groups, so that's going to be 2 to the 8. And then minus 1 because we can't have everyone in group 1 or group 2. So we get 254 options altogether. For part B, it's the exact same question, but it has the word indistinct there. So remember, 2 indistinct, so we need to divide by 2 factorial. So it would be the same answer as the previous, 254 divided by 2 factorial, which is 127. Okay, all the best with the exercise. This was hard. All the best with doing some of those hard ones at the end.